Updates for you tonight. Crews are responding right now to a new fire start tonight in Yellowstone National Park.
Installed cameras capturing an eruption from the Black Diamond Pool at Yellowstone National Park on Saturday.
Yellowstone National Park has always stood as one of the most iconic landscapes in the United States, a wilderness full of geothermal wonders, vast forests, and roaming wildlife. Yet the sudden closure of the park following satellite detection of supervolcano activity has pushed it into a new and unsettling chapter. When the announcement came, it was swift, precise, and chilling in tone. Access to Yellowstone was being shut down immediately due to satellite monitoring indicating unusual and potentially dangerous volcanic behavior beneath the park. For decades, geologists and volcanologists have watched Yellowstone closely, aware of its potential to unleash an event of unimaginable scale. But the decision to close the park signaled that the activity detected had crossed a threshold significant enough to trigger extraordinary precautionary measures. Before we start, smash the like and subscribe buttons for more updates. The story begins beneath the surface, where a massive magma chamber stretches across hundreds of miles under Yellowstone. It is this chamber, fueled by intense geological processes, that powers the geysers, hot springs, and mud pots that make the park famous. Satellite data plays a critical role in tracking subtle shifts in the land above, and in recent days, instruments have picked up rapid ground deformation, heat anomalies, and shifts in gas emissions. These are not small fluctuations. They suggest large-scale movement of magma, a reawakening of sorts in a system that last erupted on a supervolcanic scale more than 600,000 years ago. The satellites do not exaggerate. They reveal, with cold precision, patterns invisible to the human eye yet monumental in consequence. Closing Yellowstone was no trivial action. The park is a major draw for millions of visitors each year, and the surrounding communities depend on its steady flow of tourism for their livelihoods. But the stakes here go far beyond economic disruption. Officials weighed the risks of continuing to allow visitors near an area showing signs of extraordinary volcanic unrest. In the balance between safety and access, safety prevailed, and the closure became an unmistakable message. The activity unfolding beneath Yellowstone is not business as usual. It is a warning written in the shifting ground, in the data streaming from orbiting satellites, and in the tension of a geological system that humans cannot control. The satellites themselves tell a fascinating story. Using radar interferometry, thermal imaging, and spectroscopic analysis, they can measure the ground rising or falling by mere millimeters, capture invisible plumes of gases like carbon dioxide and sulfur dioxide, and detect heat signatures across wide areas. Over Yellowstone, these tools revealed a bulging of the caldera floor, a measurable uplift that suggests magma pushing its way upward. Accompanying this were spikes in surface heat, far higher than seasonal averages, and gas emissions that hinted at fresh magma degassing near the surface. Put together, this suite of signals left little doubt for scientists. Something significant was stirring. The implications of these detections ripple outward in concentric circles of concern. On the local level, the closure affects rangers, guides, hoteliers, and residents who live around Yellowstone's vast boundaries. They are accustomed to the rhythms of the park, the rush of summer tourists, and the quiet of winter. But they are less accustomed to the sudden uncertainty of a geologic system entering a volatile state. Questions arise about whether earthquakes might soon rattle the region, whether hydrothermal explosions could occur, or whether roads and infrastructure could be damaged by sudden subsidence or uplift. The closure itself then is not only a physical barrier but also a psychological one, signaling that the familiar landscape is temporarily unsafe. On a broader scientific level, the detection sharpens the debate about Yellowstone's place in global volcanic hazards. For years, experts have studied the supervolcano with a mix of fascination and dread, acknowledging its potential while often downplaying imminent risk. Yet when satellites pick up unusual activity, those long-term probabilities suddenly feel much closer. Even without an eruption, the detection forces scientists to revisit models, re-examine data, and ask sharper questions. Is this a prelude to a smaller eruption? Is it part of a natural cycle of unrest that will settle again? Or is it something more significant? A slow build toward an event with no modern precedent. The shutdown also draws attention to the sheer scale of Yellowstone's volcanic system. Unlike a typical volcano with a single cone and predictable eruptions, Yellowstone is a caldera spanning 30 by 45 miles. Its last major eruption expelled over 1,000 cubic kilometers of material, blanketing much of North America in ash. The satellite data indicating magma movement beneath such a system cannot be dismissed lightly. While the closure does not confirm an imminent eruption, it acknowledges the seriousness of what the instruments have revealed, a system capable of global impact showing signs of reawakening. The public reaction has been layered with fear, fascination, and speculation. Images of closed gates at Yellowstone clash with the grandeur of its landscapes, stirring a sense of dissonance. The park that usually symbolizes stability and beauty now carries an aura of danger. Conversations spread rapidly, with people trying to grasp the science behind the closure. Social media feeds fill with maps of the caldera, diagrams of magma chambers, and animated models of eruption scenarios. Though officials are careful to frame the closure as precautionary, the mere involvement of satellites and the mention of supervolcano ignite imaginations far beyond the scientific community. From a governmental perspective, the decision underscores the growing role of space-based monitoring and national safety. Decades ago, such a closure would have relied heavily on ground-based sensors and seismographs, which, while valuable, cannot provide the comprehensive perspective satellites deliver. Now, with fleets of orbiting instruments watching the Earth with relentless precision, agencies can act faster, respond earlier, and weigh risks with sharper clarity. Yellowstone's closure thus marks not only a geologic moment but also a technological one, a demonstration of how the marriage of Earth science and satellite technology is transforming our ability to respond to natural threats. The closure also touches on deeper questions about humanity's relationship with natural forces. Yellowstone is not simply a park, it is a reminder of the Earth's raw power, a place where magma, water, and gas converge in spectacular yet fragile equilibrium. When satellites detect that equilibrium shifting, it challenges the illusion of control. Visitors might marvel at Old Faithful's predictable eruptions, but the supervolcano beneath is anything but predictable. The shutdown confronts people with a humbling truth. Beneath the scenic beauty lies a geological engine vast enough to alter continents, oceans, and skies. For scientists working directly with the data, the satellite detections represent a moment of both opportunity and responsibility. Rarely do such clear signals emerge from Yellowstone's restless ground, and every bit of information is invaluable for advancing understanding. Research teams now pore over terabytes of data, comparing uplift patterns with past cycles, analyzing gas ratios to infer magma depth, and simulating scenarios that range from minor steam explosions to catastrophic eruptions. The closure gives them the space to conduct this work without the distraction of managing large tourist crowds, but it also adds pressure to deliver insights that can guide future decisions. The event also highlights the interconnectedness of natural systems. What happens beneath Yellowstone has implications far beyond the borders of Wyoming, Montana, and Idaho. A smaller eruption could disrupt air travel across North America, as ash clouds interfere with engines. A larger one could impact global climate, reducing temperatures and altering weather patterns for years. Even without an eruption, the current unrest reshapes how agencies prepare, how emergency services plan, and how the public perceives risk. In a world already grappling with climate change and natural disasters, the news from Yellowstone adds another layer of uncertainty. Local communities now find themselves at the intersection of science, policy, and survival. For them, the closure is not an abstract debate about magma chambers, but a tangible disruption of daily life. Businesses reliant on tourism brace for cancellations. Schools discuss contingency plans, and families weigh whether to stay or relocate temporarily. These communities live in the shadow of the supervolcano, and while many have long accepted its presence as part of life, the satellite detections bring its reality into sharper, more unsettling focus. At the same time, the closure rekindles humanity's age-old fascination with volcanoes. From Vesuvius to Krakatoa, eruptions have shaped history, destroyed civilizations, and inspired awe. Yellowstone stands at the pinnacle of this fascination, the ultimate symbol of Earth's capacity for transformation. The sudden detection of supervolcano activity and the immediate closure of the park add a dramatic new chapter to that story, one that blends cutting-edge science with the primal drama of nature. It is a reminder that even in an age of satellites and advanced technology, humanity remains vulnerable to forces far greater than itself. As days pass, the closure remains in effect, and satellites continue their vigil. Each new dataset becomes a piece of the puzzle, adding detail to the unfolding picture beneath Yellowstone. The park itself, emptied of tourists, takes on an eerie stillness. Geysers erupt to no applause, bison roam unobserved, and the land seems to breathe on its own, unburdened by human presence. It is as though Yellowstone itself has reclaimed its solitude, a vast volcanic system preparing for whatever comes next, while the world waits and wonders. In the broader scope of time, this closure may one day be seen as a turning point in how society responds to supervolcanoes. The reliance on satellite data, the decisiveness of the shutdown, and the global attention it attracted may shape future protocols for volcanic monitoring across the planet. From the Andes to the Philippines, from Iceland to Indonesia, supervolcanoes lurk beneath the surface, and Yellowstone's closure reminds the world that their activity is not just theoretical. The Earth is alive, restless, and monitored more closely than ever before. Yellowstone's shutdown is not simply a park closure. It is a story of science, technology, community, and awe. It is a moment when the deep forces of the planet broke through the surface of human routine, demanding attention and respect. Satellites orbiting far above became the eyes that saw what no one on the ground could see, and their message was clear enough to close one of the most treasured landscapes in the United States. The event stands as a testament to the fragile coexistence between humanity and the immense natural systems beneath its feet, a coexistence that at any moment can be reshaped by the stirrings of a supervolcano. The sudden shutdown of Yellowstone after satellite detections of supervolcano activity not only startled the general public but also sent ripples through scientific circles, emergency management agencies, and global observers who understand the scale of what such a system represents. The announcement was not just another park closure due to seasonal concerns or weather. It was tied to one of the most powerful natural systems on the planet. The very word supervolcano conjures images of catastrophic upheaval, and now the data suggesting real-time unrest beneath Yellowstone forces new perspectives, particularly in areas often overlooked when the conversation is dominated by apocalyptic speculation. The implications extend beyond geology, touching technology, governance, sociology, and the very way humans conceptualize their relationship to Earth. One of the most immediate consequences of this development is the renewed attention to how human infrastructure is designed in volcanic regions. While Yellowstone's supervolcano is unique in its size and potential, the phenomenon of magma movement, uplift, and gas release exists in many volcanic systems worldwide. The satellites that first picked up Yellowstone's unusual activity also watched dozens of other volcanic sites from Mount Etna in Italy to Kilauea in Hawaii. What is remarkable in this case is how rapidly the detection translated into policy action. Roads were closed, visitors were turned away, and operations within the park were halted. This sequence sets a precedent that advanced satellite-based warnings may in the future trigger swift, large-scale closures in other regions where volcanic unrest threatens human lives. Yellowstone's shutdown may become a case study in how science and government can coordinate under conditions of uncertainty, valuing precaution even without visible disaster. Another angle is the economic geography surrounding Yellowstone. Towns like West Yellowstone, Gardner, Cody, and Jackson thrive on the constant flow of visitors to the park. Hotels, restaurants, outfitters, and guides depend on predictable patterns of seasonal income. When the closure occurred, these communities suddenly faced not only financial strain, but also the realization that their prosperity is tied to a geologic system that cannot be controlled or predicted with absolute certainty. The social fabric of these towns now stretches under pressure. Local councils must negotiate between maintaining calm, supporting their businesses, and preparing for the possibility that this closure could extend indefinitely. It is an uncomfortable reminder that human settlements near natural wonders are also settlements near natural hazards, and that prosperity in such regions is always subject to disruption by forces beyond the reach of policy or planning. At a broader scale, the closure invites reflection on the role of global monitoring networks. Satellite systems are not limited to domestic agencies. International collaborations feed data into shared databases, where scientists worldwide analyze patterns of ground movement, heat flux, and gas emissions. Yellowstone's detected activity thus becomes part of a larger global picture of volcanic monitoring. Nations in the Pacific Ring of Fire, for example, watch Yellowstone with interest because lessons learned here could be applied to their own systems. The sudden shutdown demonstrates how technological vigilance can alter public policy almost instantaneously. And it highlights how natural phenomena in one country carry implications for preparedness everywhere. What happens beneath Yellowstone resonates in the Andes, in Iceland, and in the Philippines, where volcanic hazards remain a lived reality. The philosophical dimensions of the closure are equally profound. Yellowstone has long symbolized natural majesty, a place where visitors feel awe at the geysers and wildlife, often without thinking deeply about the underlying mechanics. Now the park takes on a dual identity, a sanctuary of beauty and a potential source of global-scale destruction. This juxtaposition forces visitors, scientists, and policymakers alike to grapple with the paradox of admiration and fear. The same geothermal forces that create the park's stunning features also underpin its potential danger. The closure crystallizes this paradox into a lived reality. A space once defined by leisure and exploration suddenly transformed into a restricted zone of risk. The psychological impact of this shift is considerable, reshaping how people will think of Yellowstone in the years ahead. There is also a cultural narrative emerging around the event. Stories of Yellowstone have been embedded in American consciousness for over a century. From indigenous histories to pioneer journals, from postcards to documentaries. The shutdown adds a new chapter to this narrative, one where Yellowstone is not merely a treasure to be preserved, but a threat to be managed. Already, media outlets frame the closure in dramatic terms, emphasizing the magnitude of the supervolcano beneath. For some, it becomes a symbol of humanity's vulnerability. For others, a reminder of the sophistication of modern technology able to detect danger before it manifests. In this way, Yellowstone's closure becomes more than a logistical event. It becomes a cultural marker, a shared moment in which the ancient power of Earth collides with the modern capacities of human surveillance. On the scientific frontier, the event accelerates research into how magma chambers evolve. Satellite detections of uplift and gas release provide only part of the puzzle. To understand what is happening, scientists must integrate data from seismographs, GPS instruments, thermal probes, and chemical analyses of water and rock samples. The closure creates an opportunity. With tourists absent, research teams can deploy equipment and conduct surveys with fewer constraints. Yellowstone, usually filled with crowds, becomes a laboratory once more. This heightened focus may yield insights not only about the present episode of unrest, but also about long-term volcanic behavior, improving models of supervolcano dynamics. Each new detail gathered may refine global understanding of how immense magma systems behave before eruptions, or how they sometimes simmer down without erupting at all. The closure also has implications for how information is communicated during scientific uncertainty. Officials faced a delicate balance in announcing the shutdown. On one hand, the public needed to know the seriousness of the satellite detections. On the other, exaggerated fear could spread rapidly, particularly in a digital age where rumors travel faster than verified data. The decision to attribute the closure directly to supervolcano activity ensures transparency but also fuels anxiety. Moving forward, communication strategies must walk a fine line between honesty and reassurance, ensuring that the public respects the risk without descending into panic. This balancing act highlights the broader challenge of science communication in an era where natural hazards intersect with mass media ecosystems. Internationally, Yellowstone's shutdown invites governments to consider how they would respond to a supervolcano in their own borders. Many countries have dormant or active systems capable of large eruptions, and most have populations living near them. The images of empty Yellowstone roads and blocked gates serve as a powerful visual cue that the most responsible action in the face of uncertain volcanic signals may be disruption now to prevent catastrophe later. Global agencies devoted to disaster preparedness will likely study this response as a model, assessing its strengths and weaknesses, and applying its lessons to their own volcanic monitoring and emergency planning frameworks. Beyond immediate policy and science, the closure compels reflection on the fragility of human systems in the face of planetary forces. Modern life is often built on assumptions of stability, that landscapes remain fixed, that seasons follow predictable patterns, that infrastructures endure. Yellowstone's unrest disrupts these assumptions, reminding societies that the ground beneath their feet is not static, but dynamic, shaped by forces that occasionally surge into view. In the grand narrative of Earth, human civilizations occupy only a brief chapter, and Yellowstone's stirring underscores how small shifts in geological processes can shake human confidence in permanence. The educational opportunities arising from the event are also significant. Schools and universities now have a real-time example to teach lessons about geology, risk management, and technology. Students studying volcanology can observe how data from satellites translates into real-world decisions. Those studying communication can analyze how officials manage the spread of sensitive information. Even outside of academia, the closure becomes a teaching moment for the general public, an invitation to learn about the planet's processes beyond surface appearances. Such awareness fosters a deeper respect for Earth's complexity, making it more likely that societies will support continued investment in monitoring and preparedness. If you like this video, please give it a like